In this video, I'm going to attempt 2 questions from Oxford Maths Admissions Test past papers. Now, I do not have an A-level in mathematics, so most of the questions I won't be able to answer. But what I've done is, I've tried to pick out 2 questions that don't necessarily require A-level maths skills to answer. Now, based on the timings allowed for the past papers, I've worked out that for each 4-mark multiple choice question, you shouldn't spend any longer than 6 minutes. So I'm going to give myself 6 minutes for each question. Both the questions I have selected are probability based, so I'm hoping I can use the probability that I learnt at GCSE to attempt these questions. After I have attempted both questions, I will look at the solutions to see if I got any right. Let's attempt the first question. Alice and Bob each toss 5 fair coins. Each coin lands on either heads or tails, with equal probability and with each outcome independent of each other. Alice wins if strictly more of her coins land on heads than Bob's coins do, and we call the probability of this event P1. So I'm going to write that down. So P1 equals the probability if more of Alice's coins land on heads than Bob's do. So that's event P1. The game is a draw if the same number of coins land on heads for each of Alice and Bob, and we call the probability of this event P2. So P2 equals probability game is a draw. Which of the following is correct? So we've got A is probability of event 1, 193 over 512, and P2 equals 63 over 256. We've got B, P1 equals 201 over 512, and P2 equals 55 over 256. C is P1 equals 243 over 512, and P2 equals 13 over 256. D is P1 equals 247 over 512, and P2 equals 9 over 256. And E is P1 equals 1/3, and P2 equals 1/3. So, Alice wins if strictly more of her coins land on heads than Bob's coins do, and we call the probability of P1. So if a coin is tossed 5 times, then the probability of getting 3 or more heads equals 1/2 so there's a 50% chance each time of landing on a head or tail. 6 minutes is not enough time for this. So the probability of 3 or more heads would be 1/2. Okay, let's change that. The probability of 3 heads would be 1/2 to the power of 3, which is 1/2 cubed. So that'd be 1/8. And the probability of 4 heads would be 1/2 to the 4, which equals 1/16. And 5 heads would be 1 to the 1/2 to the power of 5, which equals 1 to 32. And if we add these fractions up, so 1/8 plus 1/16 plus 1/32, that equals 216, 232, 432, so that's 7/32. So it's a draw if they both have the same number of heads. So if they get the same number of heads, the game is a draw if the same number of coins lands on heads for each of Alice and Bob. Okay, I've got 1 minute left. So 7 out of 32. Okay, I've failed. I haven't been able to get to the answer. Which of the following is correct? Yeah, this is a lot to do in 6 minutes. Okay, so the first one was a fail. Yeah. Right, we'll move on to question 2. See if we have better luck. Okay, so let's attempt question 2 now. Okay, so 6 vectors are each chosen to be either 1, 1 or 3, 2, and the vectors are v1, v2, v3, v4, v5, and v6, with equal probability, with each choice made independently. So the probability of one event happening doesn't affect the others. The probability that the sum of all the 6 vectors, the probability that the sum of the 6 vectors is equal to the vector 10, 8 is, and we've got 0, 3 over 64, 15 over 64, 1 over 6, or 5 over 16. So the vectors, we've got 1, 1, or 3, 2. I messed up. Now to add vectors together, you just add the top 2 numbers and the bottom 2 numbers. So these 2 vectors added together would equal 4 and 3. And we need to find the probability that the sum of the vectors is equal to the vector 10, 8. So we need to work out combinations of the vectors 1, 1 and 3, 2 that add to 10, 8. So what we could do is we could have 2 times the vector 1, 1 plus 2 times the vector 3, 2. So that would give us 2, 2 plus 6 over 4, vector 6, 4, and that equals 8. That doesn't work. Right. Sorry, if we do 4 times vector 1, 1, so that would give us 4, 4 plus 6, 4, and that equals vector 10, 8. So it's the probability of each vector chosen to be either 1, 1 or 3, 2 are all equal. So the probability of having 4 of the vectors with being vector 1, 1 and the other 2 vectors being 3, 2, for each of the vectors it'd be 1/6. So I think this is the only combination that gives the vector 10, 8. Sorry, so each vector has a 50-50 chance of being either 1, 1 or 3, 2. So for 4 of the vectors to be 1, 1, it'd be 4 times a half. Sorry, it'd be a half to the power of 4, which equals 1 over 16. And then, so to get 2 vectors v2 with 3, 2, it would be 1/2 to the power of 2, which would be a quarter. And then we've got 1/4 plus 1 over 16, which equals 4 over 16 plus 1 over 16, which equals 5 over 16. And 5 over 16 is an option. It's option E. So my final answer will be E. So the first question I wasn't able to get to an answer, but the second question I have. So let's see if I got it right. Okay, so the answer turned out to be C, which was 15 over 64. My approach seemed to be completely wrong. They've used simultaneous equations in the solution. I wasn't going to figure that out, to be honest, in 6 minutes. That's ridiculous. Let me know if you enjoyed this concept, and maybe in the future I'll attempt more questions of this type. But fair play to anyone who sits these papers, because these kind of questions to do in such a short amount of time, very difficult. For both of my solutions as well, please excuse the messy writing. Anyway, thanks for watching and I hope you enjoyed.